Alright, so we're on question 9 of the November 2012 Namibian higher level paper, paper 1. Question 9 says the diagram below shows a triangle ABC, in which angle ABC is 90 degrees as shown there. The vertices of the triangles are A, which is 3, 5, B, which is 12, 17, and C, which is B and 20. So this B here is unknown. Question A, find the equation of the line BC. Okay, BC, that's a straight line. So a straight line has equation y equals mx plus c. So we need to find the m and the c value. Now, the m value, that's the gradient. How do we find the gradient? Well, it's change in y over change in x. But since one of the x's values here, the b, is unknown, we cannot readily do that. But we've got something else here. We know it's a 90-degree triangle. So that is, those lines are perpendicular. Now, what do we know about perpendicular lines? For perpendicular lines, we know the gradient of the one line multiplied by the gradient of the other line is equal to -1. Okay, so that's what we'll use. So we can find the gradient of AB, because that's perpendicular to the gradient of BC. So we're going to say the gradient of AB multiplied by the gradient we want, I'm just going to call that m, is equal to -1. So how do we find the gradient of AB? Well, it's the change in y values divided by the change in x values. Okay, so let's say change in y values, so that's 17 minus 5 over change in x values, 12 minus 3. So that's the gradient of AB multiplied by the gradient we want must be equal to -1. Okay, 17 minus 5 is 12. 12 minus 3 is 9. And we multiply that by m to get -1. This we can simplify a little bit to 4 over 3 equals -1. And then we just divide both sides by 4 over 3. So -1 divided by 4 over 3 is -3 over 4. Alright, so that's our m. So far we know y equals -3/4 x plus c. And to find c, we can substitute any point that lies on our line. So our line is BC, so we can substitute any point we know. We know the values of B, so we can substitute that in. So y is 17 at B, and x is 12 at B, plus c. Okay, so let's just work that out. So 12 times -3/4, 12 times -3 is -36, divided by 4 is -9. We can take the 9 over to get 26 equals c. So finally, putting it all together, we've got y equals -3/4 x plus 26. And that is the equation of line BC. Okay, that was quite a bit of work. Now let's look at question B. Question B. And question B is quite nice. It just asks us to find the value of B for question B. Pretty cool. Okay, so B is this value here. Now what we can do is a couple of things. We can say we know the gradient, so we can use the gradient formula. We know the whole equation, so we can use the equation. So there's a couple of things we can do. So let's actually do both methods. Let's say we just use the equation we just solved. So the equation BC. Equation BC was y equals -3/4 x plus 26. And then we just substitute point C in. So y is 20 when x is b plus 26. And I always solve for b from there. So I'm going to take this over to that side, which gives me 3/4 b equals 26 minus 20, which is 6. And then I just divide both sides by 3/4. So 6 divided by 3/4 is 8. And that's the value of b. Fantastic. Option 2 would have been to use what do you call it? Sorry, I'm a little bit tired. It's 1 in the morning. The gradient formula. Okay, so we know the gradient. Let's just write in the gradient formula. Gradient formula is the change in y values divided by the change in x values. Okay, so we'll just use that. Now the gradient for BC, we calculated to be -3/4 here. So we can say -3/4 is equal to, and let's do the change in y over change in x thing, 17 minus 20 for the y values, over, and then 12 minus b for the x values. Okay, so to solve for b, let's multiply both sides by this denominator. So we'll have negative 3/4 times 12 minus b is equal to 17 minus 20, which is negative 3. So now you can choose, do you want to multiply this in, or do you first want to divide by it? Doesn't really matter. I'm going to divide both sides by negative 3/4 to start with. So what we'll have is 12 minus b equals, and negative 3 divided by negative 3/4 will give us 4. Alright, and now we just get b by itself. So I'm going to keep 12 minus the 4 to the side and take the b over. 12 minus 4 is 8 equals b. So we see we get to the same answer, a couple of different ways. And if you did any other way, or you've got another question of maybe can we do it this way, can we do it that way, let me know in the comments below and we can discuss that. Good, and then finally question C, the last one for this video, I think. Let me make sure. Yes, that's the last one for this video. Question C, find the length of BA. Okay, so the length of BA, we can just plug that straight into our length. Sorry for that. We can just plug these values straight into our length formula. Now, before we do that, let's see where this length formula comes from. This length formula is actually just Pythagoras in disguise. So what we can do from A to B, we can imagine we've got a right angled triangle, because it does form a right angled triangle right here. So how would we find the length of this part of the hypotenuse? Well, we'd say this side squared plus that side squared equals this side squared, right? Remember Pythagoras. So how do we get this distance here? Well, since this is a 90-degree triangle, it's horizontal and vertical, this is just a difference between the x values, right? So x2 minus x1 gives you this distance, and y2 minus y1 gives you that distance. So all we want to do to find the length, so the distance AB is just equal to, well, AB squared, hypotenuse squared, equals x2 minus x1 squared plus y2 minus y1 squared. And to get AB by itself, all we do is we take the square root of that. And that is our distance formula. So that's where it comes from. Okay, great. Let's just plug it in to find our actual case. So we've got big square root. We want to do difference between the x values. So let's say 12 minus 3. So 12 minus 3 squared plus, then y values, 17 minus 5. So 17 minus 5 squared. And we still need to take the square root. Alright, so from here, I mean, you can just type in your calculator. I'm just going to work it out by hand. So 12 minus 3 is 9, 9 squared is 81, plus 17 minus 5 is 12, 12 squared is 144. Take the square root of that, so that's the square root of 225. And then finally, the square root of 225 is 15. So there we have the distance for AB. Alright, I hope that was useful. Maybe it was nice to see where this formula comes from instead of just learning it and memorizing it. You can see it's actually just Pythagoras. So it's nothing new, it's not a new formula that you have to learn. If you know Pythagoras, you know this formula. Alright, I'll see you pretty soon again for question 10. We're nearing the end of this paper now.